This one is from Airbnb, and it's considered a quote-unquote hard one, and I think it kind of is. We are given a list of integers, and we're supposed to write a function that returns the largest sum of non-adjacent numbers. And numbers can be 0 or negative, so we have to really keep that in mind. For example, the array of 2, 4, 6, 2, 5 should return 13 because you have the number 2, the number 6, and the number 5. And notice that they're non-adjacent because if it was adjacent, that would violate the rule. So we need to actually keep that in mind, that we need to skip values. Conversely, the array 5, 1, 1, 5 should return 10 because the 5 and the other 5 can add up to 10. And notice that we're skipping 2 in this case. So these are still not adjacent, even though you're skipping 2. That's totally okay. So we need to get this worked out, and the follow-up is that if we can do it in big O of n time and constant space. So first, the question doesn't really answer what I have in mind is like, what if the array is empty, or what happens if you get, just an array of like 1 or 2 values. So that is an answer. I will answer that myself, which is that the array can't be empty, but it could be length 1 or 2 or 3 or whatever. So that is what I'm going to be keeping in mind. So I'm going to have my base cases here of 1 and 2. So I'm just going to say, hey, these are, it can't be empty basically, and everything else is going to be more than 3. So 3 or more length will be my other situation. So here's how to think about this. Once you're past, like, let's say for the example here, so once you're past these first 2, you don't really care which position you're in at that point, because as long as you're past the first 2, that whole idea of like alternating doesn't really matter too much, because like we saw here, like it doesn't really matter that this 1, it can be skipped. It's totally fine. If array.length is equal to 1, then I'm just going to return the value in that 1, because that's the highest sum it could be, right? So that's array r0. Okay, easy done. And if the length is equal to 2, well, then I want to make sure that I return the max of those 2. So that's r1 and r0. And that's my base case already done. All right, what about length 3? So length 3 we have to think about. So the way that you can do this is like this this approach where you're basically keeping track of the value you've seen so far and updating accordingly. So this is kind of like a dynamic programming solution. For the first 2 positions, we need to keep track of like the highest that we've seen, right? So here at position 1, we see 5, so that's the highest at that point. Here we see 1, but we're going to keep track of the highest at that point, which is 5. And again, I know it's like, what about the skipping idea? At this, because we know that the length is 3 or more, we can have the confidence that it's not going to affect the end result, because it is already, it's as good as it's going to be. The third position, we look at 3 criteria. First, we look at the current max, which is 5. That's the current max period, right? And then we say, okay, well, that's the max. Can I beat it? And the way you beat it is by looking at the value that the max that we had two steps ago, and that was 5. Okay, we take that 5, we add 1, and we get 6. 6 is bigger than the 5, so we have to say 6 at this point is the biggest that we can get. Then we go to 5, and we say 5. Okay, 5. The current max is 6. Are you better than 6? The answer is no. Okay. Well, what about the max from 2 steps ago? That's the 5. Well, 5 plus 5 is 10, and then that becomes our max. And the last number is going to be our max period. And that's how this algorithm is basically going to work. So that's what I'm going to be doing. And I think I can do this in place because this array doesn't really matter at that point. So I will be eventually returning the array because I'm going to be doing all this stuff in constant space, basically. And I'm going to loop through it 1 time. So you can do it, and this is how it looks. Okay, so let's do a for loop for I, let I equal 0. I is less than array.length, and just I plus plus. And that's all we're doing, okay? We need to set these things up first. So let's keep that in mind. I need to set these 2 max, these up. R of 0. Well, R0 is already itself, so I don't need to do that. R of 1, though, needs to be equal to the max of that point. So this is why I'm setting it like this. And that sets us up to the situation I had before, which is like this, 5, 5, and I don't even need to start at 0 now. I can start at 2, the third position. So I started the third position, and I can go forward from there. And I'm going to just make very explicit like what we're keeping track of here. So we have the max so far. Let max equals, actually I want to let max equals to this because that's technically what it is. That, and then you're equal to the max at that point. So const, we have our val, which is current. I'm going to call this current number, array I, right? Okay, current number, and I need to have I need to compare it to the max. So if current number is greater than the max, or if the max is less than the current number, then we're actually done. We can say, hey, max, you're now equal to the current number, because up to that point, that's the max that you found. Going 2 steps behind isn't going to help. I think I need to go to the previous num too. Const 2 back, array of I minus 2. So that's 2 back. That's the one that you're looking for. Yeah, so I think it's weird to not have the current max here. So I'm going to have the current, if the current number is bigger than the max. By the way, I'm returning the array in the last position, minus 1. I think I need to do, so if cur num plus 2 back is bigger than the max, then max equals that sum basically. Const sum equals that. So that is sum, and that is what you get. Else if, right, so here's the situation. So imagine that these are like negative numbers too. So this is the kind of situation that we're kind of trying to avoid here. Yeah, so these are negative numbers. So this max value so far is -1, and this is also -1. And here, the max value will be 1. How did I get 1? I had to effectively ignore the current maximum. So if the max is less than the sum, then great, set it. Else if the current number is greater than the max, we basically just ignore the max so far, because the current number is just like above and beyond what it would have been. So you need to just ignore that, the previous max basically. So max equals current number. Else the max is fine, so we don't need to change it. Okay, and then we set array I to that max. And I think, let's see, my length is that. So let's double check this. So if -1 comes in here, we get the max is -1, -1. 1 comes in, 1 is bigger than the max so far, and it's certainly bigger than the one 2 ago. Plus 1, that would be 0. So that's that would work. Sorry, that would work here, actually. Huh. I'm gonna do it like this. Does that make sense? Like, if that, set it to max. Hold on, this is like. So if max is less than the current number, then the current number is a good candidate, right? All right, I'm gonna try this. Let's try this out and see what it looks like. Okay, I got 13 there. I want to see what I get in this situation here. So this should run me a -6 on that one. I got 5. Yeah, okay, that makes sense. Yeah, so that I corrected myself with my own code. That's interesting. So this is going to be 5 because it is it can't count adjacent. So it's literally like ignore these, and 5 is the biggest that it can be. I definitely like the idea of like the dynamic programming approach. It is very quick. That is my solution for that. I hope that was useful and enjoyable. I definitely consider this to be a hard one. It took me a long time to understand the logic of this before I saw it today. But now that I know, I'm familiar with it, I'm a little better at handling these dynamic programming problems, hopefully. Anyway, see you next time.